Section 5.7, Completing the Square. On previous sections, we learned how to solve quadratic equations by factoring, square roots, and graphing. Here, we want to solve a quadratic equation by perfect trinomials. In other words, what I need is a trinomial on one side of the equation that is a perfect trinomial. In other words, it'll break into a product of binomials that are exactly the same. In this example, we have that situation. So I can factor the left side of the equation because I know 49 will break into 7 times 7, which is 49, but 7 plus 7 is 14. So here, my binomials are going to be x times x, and 49 will break into 7 times 7. And when I FOIL, I need my 7s to be the same sign, but they have to be negative because of my middle term. Therefore, a negative times a negative is a positive 49, but a minus and a minus gives me a negative 14. Now I can write this in such a way that I have x minus 7 squared equals 144. Now I can take the square root of both sides, and that gives me x minus 7 equals a plus and minus 12. Now I can solve two equations, one being x minus 7 equals a positive 12. When I add 7 to both sides, x equals 19, and x minus 7 equals a negative 12. When I add 7 to both sides, I get x equals a negative 5. Therefore, my two solutions are 19 and a negative 5. Here they want me to solve the equation x squared plus 10x plus 25 equals 8. This is a perfect trinomial because when I factor, I know 25 will break into 5 times 5, which is 25, but 5 plus 5 is 10. Therefore, when I factor, I can get x times x, 5 and 5, and I have a plus sign and a plus sign, so this is plus, plus. I can rewrite x plus 5 quantity squared equals 8, and then take the square root of both sides. That gives me x plus 5 equals, and I know the square root of 8 can be written as a product of factors, one being a perfect square, is going to be the square root of 4 times 2, but that's going to simplify to plus or minus 2 square roots of 2. Now I break that into two equations. X plus 5 equals 2 square roots of 2. I subtract 5 on both sides. X equals a negative 5 plus 2 square roots of 2. And then I can write the other equation. X plus 5 equals a negative 2 square roots of 2. Subtract 5 on both sides. X equals a negative 5 minus 2 square roots of 2. And here's my two solutions. When trying to solve quadratic equations by a perfect trinomial, you may run into situations where one side is not a perfect trinomial. But you can rewrite the constant term to get it to be a perfect trinomial. The process of doing that is called completing the square. That's completing the square is the process of finding the constant term of a perfect trinomial. For example, if I have x squared plus bx, I can make this into a perfect trinomial by the procedure of taking b, which is my coefficient of my linear term, dividing it by 2, and then squaring it. If I do that, I can then rewrite that as a product of factors in such a way that I have x plus b over 2 squared. In other words, this would break into x plus b over 2 times x plus b over 2. And of course, then I can rewrite it as x plus b over 2 squared. In this example, they want me to complete the square. In other words, they want me to find the missing term given my quadratic and my linear term. So here, what I have is my b, which is a negative 5. Then I want to take b divided by 2, which will be a negative 5 over 2. And then I want to square that, which will equal 25 over 4. So that is my missing term. Then I could write this as x minus 5 over 2 quantity squared. Here I have b, which is 2/3. I need to divide that by 2. It is going to give me 2/3 divided by 2, which equals 2/3 divided by 2, which is times 1/2, which equals 1/3. Now I want to take b over 2 and square it. 1/3 squared is going to be 1/9. So my missing term is 1/9. Now I could write this as x plus 1/3 quantity squared. Here's the procedure to solve a quadratic equation by a perfect trinomial, but we need to use completing the square. One, we need to get the square term and the linear term on the same side of the equation and get the constant term on the opposite side. Next, we need to find b over 2 quantity squared, completing the square, add b plus 2 quantity squared to both sides of the equation. That'll keep my equation balanced. What I do to one side, I need to do to the other. Then I need to factor the perfect trinomial. And then 5, take the square root of both sides and solve for the variable. In this example, they want me to solve each equation by completing the square. From the previous procedure, I need to get my constant term on the opposite side of my quadratic and linear term. So I'm going to have x squared plus 4x equals, add 4 to both sides, I get 4. Now I want to complete the square. My coefficient of my linear term is b equal to 4. I want to divide that by 2, which gives me x squared plus 4x. And when I divide it by 2, I'm going to get 2. And when I square it, is going to give me 4. 4 divided by 2 is 2. Squared, I get 4. I'm going to add 4 to both sides. That will balance my equation. Now this becomes a perfect trinomial. I can factor that, x plus 2 and x plus 2 equals 8. And if I FOIL, I can see that is a perfect trinomial. X squared plus 2x plus 2x is 4x. 2 times 2 is 4. Rewriting that, x plus 2 quantity squared equals 8. Now I can take the square root of both sides, and that gives me x plus 2 equals plus or minus, and again we have the square root of 8, which I know breaks into the square root of 4 times 2, which is going to give me plus or minus 2 square roots of 2. Now I can have two equations to solve. X plus 2 equals a positive 2 square roots of 2. Subtract 2 on both sides. X equals a negative 2 plus 2 square roots of 2. And the other equation is x plus 2 equals a negative 2 square roots of 2. And when I subtract 2, that gives me x equal to a negative 2 minus 2 square roots of 2. For example, if I substituted these two quantities into a calculator, I would get approximately 0.828 for a negative 2 plus 2 square roots of 2, and a negative 4.8 for a negative 2 minus 2 square roots of 2. And from previous sections, we knew that we would solve this quadratic by graphing. And if I did that, you could see that I would end up with the same solutions. And here is my 0.828 or 0.83. And here's my negative 1, 2, 3, 4.8. Now we just have another procedure to solve quadratic equations other than graphing. We can do this by completing the square. Again, they want to solve this equation by completing the square. Following the procedure, I'm going to get my constant term opposite my linear and quadratic term. That gives me x squared minus x equals 1. Now I want to complete the square. My b is a negative 1. b over 2 is a negative 1/2. And b over 2 squared is 1/4. Let's substitute that in as my constant term for my trinomial and add to both sides to balance the equation. X squared minus x plus 1/4 equals 1 plus 1/4. This is a perfect trinomial, so I can factor. That's going to give me the product of two binomials. That gives me x and x. 1/4 will break into 1/2 times 1/2. That will be negative and negative. A negative 1/2 times a negative 1/2 is a positive 1/4, but a negative 1/2 x plus a negative 1/2 x gives me a negative 1. Then I can add 1 to 1/4. I get 1 and 1/4. Then write this as x minus 1/2 squared equals, then put this into an improper fraction, which will give me 5 over 4. Then I can take the square root of both sides. That gives me x minus 1/2 equals plus or minus the square root of 5 over the square root of 4, which I know is 2. Now I can write that as two equations and solve for the variable. Here I'm going to have x minus 1/2 equals a positive square root of 5 over 2. I'm going to add 1/2 to both sides. I get x equal to a positive 1/2 plus the square root of 5 over 2. Since they are a common denominator, I could write that as 1 plus the square root of 5 all over 2, but this works just fine. My next equation, I have x minus 1/2 equals a negative square root of 5 over 2. Add a half to both sides. X equals a positive 1/2 minus the square root of 5 over 2. Again, since they're a common denominator, I could rewrite that as 1 minus the square root of 5 all over 2. But this works just fine. And if I would substitute these into a calculator, you can see I would get, for 1/2 plus the square root of 5 over 2, 1.6, and 1/2 minus the square root of 5 over 2, a negative 0.6. And from a previous section, if I graph that, here are my solutions, which would be approximately 1.6 and a negative 0.6. Again, this is just another way of solving a quadratic equation without graphing. Again, in this example, they want me to solve by completing the square. Let's start by getting our quadratic and linear term isolated. So I'll have x squared plus x equals a negative 1. Let's complete the square. That gives me b equals 1. b over 2 is 1/2. And then b over 2 squared is 1/4. Let's add that to both sides of my equation to balance the equation. That gives me x squared plus x plus 1/4 equals a negative 1 plus 1/4. This is a perfect trinomial, so I can break that into a product of two binomials. And a negative 1 plus 1/4 is a negative 3/4. This breaks into x and x. 1/4 can break into 1/2 and 1/2. And this is positive, that's positive, so it's plus plus. And that works because 1/2 times 1/2 is 1/4. 1/2 x plus 1/2 x is 1x. I can rewrite that as x plus 1/2 squared equals a negative 3/4. Take the square root of both sides. Gives me x plus 1/2 equals plus or minus the square root of the negative 3 over the square root of 4, which we know is 2. And from previous sections, I know I can rewrite that as plus or minus. We know that the square root of a negative 3 can be broken into the product of factors of the square root of a negative 1 times 3. The square root of a negative 1 is I. Square roots of 3 over 2. So we know this is an imaginary number. Now I can have two equations. First one, x plus 1/2 equals a positive I square roots of 3 over 2. Subtract 1/2, x equals a negative 1/2 plus I square roots of 3 over 2. We know this is imaginary, and therefore the solution, if I graphed it, would not cross the x-axis. My next equation, x plus 1/2 equals a negative I square roots of 3 over 2. Subtract 1/2, x equals a negative 1/2 minus I square roots of 3 over 2. Again, this is an imaginary number. And that's why, if I would have graphed this in previous sections, I would have gotten a parabola that does not intersect my x-axis. And that's why both of my solutions, when completing the square, are imaginary numbers.